Have you ever observed a pattern and thought of analyzing what and how many shapes are present in it? Or have you ever wondered how these shapes cover the entire plane with no gaps and no overlaps? If you are unfamiliar with what I mean by this, then you might have to tune in, as this video will delve into tessellations, which are relevant to the questions I asked. Let's start. So what are tessellations? Tessellations came from the Latin word tessellatus, meaning of small square stones, and from the Greek word tessera, meaning four. Tessellations are a special type of tiling which has a pattern of geometric shapes that fill a two-dimensional space with no gaps and no overlaps that repeats forever in all directions. They can be composed of one or more shapes as long as they perfectly fit together according to some set of rules, and it can be created with translations, rotations, and reflections. Before getting into examples of tessellations, let me discuss more about its origin. The origin of tessellations can be traced back to 4,000 years BC, when the Sumerians used clay tiles to compose decoration features in their homes and temples. From there, tessellation found its place in the art of many civilizations, from the Egyptians, Persians, Romans, and Greeks, to the Byzantines, Arabs, the Japanese, Chinese, and the Moors. During the Middle Ages through the 19th century, a group of intellectuals began observing tessellation present in nature in order to explain its geometric structures, which resulted in numerous studies based on mathematics. There are two notable persons that made the word tessellation well known today. First is Maurits Cornelis Escher, a Dutch graphic artist famous for his work with mathematical prints using tessellations. Although he experimented with different ways to make a tessellation, in Escher's work, tessellations follow only one repeating pattern that can be manipulated for effect. Another is Sir Roger Penrose, a British professor of mathematics at Oxford University. He compared his work on tiling to the artwork of M.C. Escher. This led Penrose to discover Penrose tiling, in which a set of shapes can be used to cover a plane without using a repeating pattern. Because of his exploration of new ideas and uses for tessellation patterns, Penrose is sometimes considered the modern inventor of math tessellations. Due to the work of graphic artist M.C. Escher and mathematician Sir Roger Penrose, tessellation is used to describe patterns in both art and math. With math and art being related to tessellation, is it considered math or art? Well, it is said to be that tessellations in art are usually shapes, patterns, or figures that can be repeated to create a picture without any gaps or overlaps. While tessellations in math, according to Drexel University, are recognized as coverings of a plane or surface without any gaps in the tiling. Let us now discuss the different types of tessellations. These are the regular tessellations, semi-regular tessellations, demi-regular tessellations, irregular tessellations, and other types such as three-dimensional tessellations and non-periodic tessellations. First is regular tessellations. Regular tessellations are formed by only one type of regular polygon. These regular polygons are all of the same shape and all meeting vertex to vertex, making it highly symmetric. There are three shapes that can form this type of tessellation. First is an equilateral triangle, a triangle with all three sides of equal length. On the right are examples of regular tessellations that are formed by an equilateral triangle. This type of design is commonly found on kitchen and bathroom walls. Also take note that tessellations have interior angles that totals to a divisor of 360 degrees. With this, the interior angles of an equilateral triangle totaling to 180 degrees is a divisor of 360. Next is a square. A square is a regular polygon with four congruent sides. On the right are examples of regular tessellations that are formed by a square. This type of design is commonly found on plain floor tiles and even chessboards. Also, the interior angles of a square totals to 360, also a divisor of 360 degrees. Last is a regular hexagon, a six-sided polygon with vertices equally spaced around the circle and with all sides the same length. Examples of regular tessellations found on the right are formed by regular hexagons. This type of design is commonly found on walls, mirrors, and even cabinets. Its interior angles totals to 720, a divisor of 360 degrees. The next type is semi-regular tessellations, which are formed by more than one type of regular polygon. Each vertex point in this type is surrounded by the same regular polygons organized in the same cyclic order. Moreover, within the limit of the same shape surrounding each vertex, there are 8 of such tessellations which comprise of different combinations of equilateral triangles, squares, hexagons, octagons, and dodecagons. On the right shows the examples of semi-regular tessellations which shows the different combinations mentioned. As seen on the last row of the first column, there is a combination of a square and an equilateral triangle, while on the second row of the second column, there is a combination of an equilateral triangle and a regular hexagon. And there are many more other combinations. Another type is demi-regular tessellations. Demi-regular tessellations are tessellations that combine 2 or 3 polygon arrangements. In addition, it always contains 2 vertices. It can be formed by placing a row of squares, then a row of equilateral triangles that are alternated up and down, forming a line of squares when combined. With this, there are 20 types of such tessellations. Next type is irregular tessellations. Irregular tessellations are composed of a group of shapes that have the sum of all interior angles equaling 360 degrees. It consists of figures that are not composed of regular polygons but still interlock without gaps or overlaps. It is the one in which there are no restrictions regarding the shapes used or their arrangement around vertices, making it a tessellation that can be formed with an infinite number of figures. There are also other types of tessellations such as the three-dimensional tessellations and non-periodic tessellations. Three-dimensional tessellations use three-dimensional forms of shapes when forming a pattern, while non-periodic tessellations is a tiling that does not have a repetitive pattern since it evolves as it is created, yet still contains no overlaps or gaps. After discussing the different types of tessellations, let us move on to the areas where tessellations are present: nature and architecture. Tessellations form a class of patterns found in nature. Examples are honeycomb, snakeskin, and cracked mud. It can be seen that the honeycomb is formed by arrays of hexagonal cells, while the snakeskins were diamond-shaped scales. Meanwhile, cracked mud is formed with different shapes and different sizes of shapes. Lastly, certain types of flowers can also be an example. Due to the simplicity and complexity of tessellations, there are famous architectural landmarks that employ exquisite patterns, such as London's Swiss Rebuilding and the Arab Hall at the Leighton House Museum, and Spain's Alhambra. Based on tessellations in nature and architecture, it is evident that tessellations have a huge impact on some of the decorative structures that we see in our everyday lives. After talking about the relevance of tessellation in nature and architecture, let us talk about its importance in different fields. First importance is the role of tessellations in providing coverings for walls, pavements, and ceilings of many facilities. Next is tessellations, making up a rich history of mosaic and mural paintings. Another is assembling tessellation puzzles, which combines art and math, encouraging creativity. Lastly is the contribution of tessellations to the world of graphic art today, showing how art fuses with mathematics and science, and how repetition of patterns is put to use. Now, before ending the video, I would like to do this activity. You can also do it too at your homes. Don't forget to take a picture of these tessellations. On the next slide are the tessellations that I found at our home. I found tessellations in our walls, tiles, and a bag design. Due to the activity, I realized that learning about tessellations made me be attentive on the different designs at our home. To sum up, tessellations are everywhere, and learning about it in the context of mathematics give a deeper understanding on its relevance in art, nature, and the everyday lives of the people. Personally, I realized that what I thought was complex when it comes to patterns was considered to be something simple while learning about tessellations. Ending the discussion, I hope you learn a thing or two about tessellations and recognize these learnings on your encounter with tessellations in your everyday life. Here are the references used in this discussion. Thank you!